Hello, and welcome to our Material Balance project video. And this video will be presented by our Baymax group, which is Group 5. And now is the time to meet the group members of Group 5. To start things off, it will be me. The first member will be me, Liu Ge, matrix number 218466. The second group member will be Chang Zi Chin, matrix number 224580. The third group member will be Khoo Yin Xuan, metric number 225397. The final group member will be Chu Mei Wing, metric number 224324. And without any further ado, let's take a look at our production plan. Welcome to Baymax plant. And the aim of our production plan is the production of nitric acid, 70% volume by volume total. And our feedstock per annum will be 1 million tons. And the method of production in our production plant will be the Baymax method, and which is a way of dual pressure method. And our feed material will be 50% nitrogen and 50% hydrogen. And then I'm going to talk about nitric acid. Nitric acid, known as HNO3, is a clear, fuming, and extremely corrosive liquid with a freezing point of -42 degrees Celsius and a boiling point of 83 degrees Celsius. It is widely used in laboratories and play a crucial role in the industrial production of fertilizers and explosives. And this substance is toxic and has the potential to cause severe burns, so be careful around nitric acid. And the primary way nitric acid is to be produced is through the catalytic oxidation of ammonia, in the method pioneered by German catalyst Wilhelm Ostwald in 1901. Ammonia gas undergoes sequential oxidation to form nitric oxide and nitrogen dioxide. This process occurs with the help of air or oxygen in the presence of platinum gauze catalyst. The produced nitrogen dioxide is then absorbed in water to create nitric acid. The result solution contains about 50 to 70% of acid by weight and can be dehydrated through distillation with sulfuric acid.
Hello everyone, I'm Khoo Yin Xuan, number metric 225397 from Group 5. Today I'm going to talk about the method our group uses to produce weak nitric acid, which is Baymax dual pressure. The dual pressure process uses two different pressures during nitric acid production. It uses medium pressure for the compressed air used in ammonia combustion, then compresses to high pressure to optimize the absorption of nitrogen dioxide. Such dual pressure plants are characterized by a high ammonia yield, low platinum losses, and long operating periods of the combustion unit on the one hand, and by a high degree of oxidation and low reaction volume in the adsorption unit on the other hand. Besides that, it is an attempt to capitalize on the best of both mono processes. The dual pressure process can realize up to 1,500 tons per day of nitric acid with one ammonia combustion and process gas cooler unit installed. Regarding Baymax technology, we may refer to Table 4, which has summarized the principal features of some commercial nitric acid processes available to operators under license. By consulting this table, we can determine the pressure to be used in the combustion unit, oxidation unit, and adsorption unit. Let's focus on the Baymax combination category, which indicates the approximate operating pressures. For the combustion unit, the approximate operating pressures PAPS are listed as 1, 4, or 8. Meanwhile, for the oxidation unit, so as adsorption unit, the pressures to be noted as 4 or 8. Consequently, our group has decided that for the combustion unit, an oxidation unit will take place at a pressure of PABS equals to 4 bar, while the adsorption will occur at a pressure of PABS equals to 8 bar.
Hi everyone, my name is Chu Mei Wing, machine number 224324. So for my part, I will present about the Material Safety Data Sheet, MSDS. So first of all, what is a MSDS? A MSDS is a technical document which provides detailed and comprehensive information on a control product related to health effects of exposure to the product, hazard evaluation related to the product's handling, storage or use, measure to protect workers at risk of exposure, and emergency procedures. So the first MSDS we are going to have a look at is the ammonia MSDS, which is right here. As you can see, ammonia. So under the hazard statement section, we can tell that ammonia is a flammable gas, and one of the prevention is that we have to keep away from heat, hot surfaces, sparks, open flames, and other ignition sources, and we should never smoke when we are dealing with ammonia gas. So one of the first aid measure is that in the case of contact with ice, rinse immediately with plenty of water and seek medical advice from doctor. So for the handling and storage section, for handling, use equipment rated for cylinder pressure. Cylinders should be stored upright with valve protection cap in place and firmly secure to prevent falling or being knocked over. And for the storage part, flammable storage areas should be separated from oxygen and other oxidizers by a minimum distance of 20 feet or by a barrier of non-combustible material at least 5 feet high. And then for the next MSDS is that nitric acid MSDS. So here is the MSDS for nitric acid. So under the hazard statement section, it can cause severe skin burns and eye damage, and it may intensify fire as an oxidizer. So one of the prevention is that we should keep away from heat and store away from clothing and other combustible materials. So let's take a look at the first aid measures. For minor skin contact, avoid spreading material on unaffected skin. In case of contact with substance, immediately flush skin with running water for at least 20 minutes. Now let's take a look at the handling and storage section, which is here. For handling, handle an open container with care, use only with adequate ventilation. For storage, we have to keep container tightly closed, store in a cold or low temperature, well ventilated, dry place away from heat and ignition sources. Okay. So due to the shortage of time, we have only included 2 MSDS in this video. So for more information, please check out our Wix website. Thank you.
Now I'm going to explain about the overall process in our block flow diagram. Our project aims to produce weak nitric acid. The processes that are required in this type of production include oxidation, condensation, and absorption as our 3 main units. The feedstock given is 50% of nitrogen and 50% of hydrogen. We fix 100 mol per hour as our basis to obtain the input value. So before undergoing ammonia conversion, we have to prepare the ammonia for ammonia synthesis. After the reactor 1, nitrogen, hydrogen, and ammonia gases enter the condenser 1. And in this condenser, part of the ammonia will condense as liquids, and the rest of them remain as gaseous states and to be discharged from this column. The ammonia liquid enter the evaporator. Since ammonia conversion has to be carried out in gaseous states, so evaporator have to be set up to convert the ammonia liquid to ammonia gases. In the combustion column, ammonia gas will react with the compressed air to produce high yield of nitrogen monoxide and water. Next, the product stream from the combustion will contain ammonia gas, oxygen gas, nitrogen monoxide gas, water, and nitrogen, which will enter the condenser, and there are water to be removed as liquids, but still have part of the water will be released as water vapor, and together with the ammonia, oxygen, and nitrogen dioxide gas. In the oxidation column, nitrogen monoxide will react with the oxygen in excess air to produce higher production of nitrogen dioxide. In low pressure system, we need high pressure and low temperature. So the compressor setting up in between the oxidation nitrogen monoxide and the absorption tower. Therefore, the gases are compressed again and the temperature is lower. The gas stream that enter these absorption units containing the nitrogen monoxide, oxygen gas, dinitrogen tetroxide, nitrogen dioxide, ammonia gas, nitrogen gas, and water vapor. In the absorption tower, nitrogen dioxide will be absorbed in the water to produce nitric acid and nitrogen monoxide gas. So the product stream in this column will be nitric acid, nitrous acid, and the water liquid. And the tail gas contain ammonia, oxygen, and nitrogen gas, dinitrogen tetroxide, nitrogen monoxide, and nitrogen dioxide. And that's all for the block flow diagram. Next, I will explain the intent of each unit that involved in the block flow diagram. Firstly, in ammonia synthesis, the reactor 1 functions as producing ammonia gases. By setting the temperature at 500 degrees Celsius and pressure at 270 to 350 atmospheric pressure, the condenser 1 is to separate the ammonia from the gas mixture using the difference of boiling point. Evaporator, it changes the state of ammonia. For the compressor, it provides a high pressure condition so that more amount of desired product can be produced. In the ammonia combustion column, it will be set up at high temperature and atmospheric pressure with the addition of suitable catalysts to provide optimum oxidation of ammonia gas so as to produce larger amount of nitrogen monoxide. Cooler condenser is to lower the temperature of gas stream and remove parts of the water as liquid. For the oxidation of nitrogen monoxide, it oxidizes nitrogen monoxide in order to produce nitrogen dioxide, which need to be absorbed in absorption column. The second compressor is to increase the pressure and lower the temperature, increase the yield of desired product. Lastly, absorption tower is to absorb the nitrous gas and produce nitric acid in a high pressure and low temperature condition.